In this video, I'm going to talk about how you can recode some of the outputs on the instrument cluster. In particular today, I'm going to talk about the coolant temperature output that you see in the instrument cluster, as well as the speed. And the reason you may want to do this is because at the moment the indication that you get is filtered. So for example, most of the speedo indications are reduced slightly. So for example, if you are doing 80 kilometers an hour, it'll show you as doing 82 kilometers an hour, that sort of thing. And so if you want to see exactly what's going on, like the actual coolant temperature, rather than being filtered and just sticking at 90 the whole time, this is the way to do it. So you need to be in PIWIS development mode. If you don't know how to do that, have a look at the other videos that I've made on how to code in PIWIS. That'll show you how to do that. And then this is all in German, so Google Translate might be your friend if required, but I'll show you how to do these and which options to go to. I'm going to firstly go to Combi Instrument, and then this one here, Codering S and Passion, or whatever it is, which is just coding. And then we want to go to the top one there, which is manual coding on MCR Reglan, which is without MCR rules. Next, and this will list, there are just reams and reams and reams of these things, and down the bottom here there's lots of, for example, you can remove different warnings that pop up or make sure they pop up, that sort of thing. But what we're going to look at today, to start off with, is come down to this one here, this cool Wasser temperature, which basically translates to cooling water temperature, hopefully a coolant. And the way this works, that there, if you think about it, there's a graph with an X and a Y axis. We've got X and Y options here. And the X is the input temperature from the DME, which is the actual temperature, and Y is the output. You can grab all of these, and what we're going to do is change the Y outputs to equal the X output. So let's just rattle off all of these there. So I've selected all of those. Let's go next. So once you open this up, what you'll notice is there are 8 values for the X, which is the actual input temperature, and there are going to be 8 values for Y, which are the actual output temperatures that you would see. Now I've changed all of these so the X's are the same as the Y. So basically all I did was I looked at all the X's here, so the input temperatures, and I made the Y's equal to those. And I'll just change one here just so you can see what's going on. The temperature, just so we can sort of have a bit of a play with it, the temperature at the moment is 42 degrees Celsius, so it's obviously in between these Y graphs here. What I'm going to do is change this to 20, just to show you what you do. You click in another area, and then I'm going to go down here, FA Scroven, which is save. And if I now go to the temperature in the instrument cluster, because it happens live, that's immediately changed to 31 degrees from the 42 that it was. So now what I want to do is go back and change that back to 36. So that's correct. And then it'll show me the correct temperature in the instrument cluster. Now, if I look at the instrument cluster, it's gone back to 41 degrees again. So hopefully that makes sense of what you're trying to do. Just make all the Y's equal the X's. Now I suspect that you could quite happily just go along and just make these sensible temperatures. Make that 0, 30, 60, 90, and just make all the others exactly the same. And it would have exactly the same effect. But all I've done there is just obviously make the Y's equal the X's. Under all of those other options, if you scroll down, you'll find this one here, tacho, whatever that is. And there are a bunch of options here. You can see that we've got that word there, which actually means speedometer, RDW, which I think means rest of the world. And if I continue to scroll down, you can see I've got X's and Y's for rest of the world. Then I've got a UK option and a USA option. And what they do is they make corrections to the speedometer. So for example, if you're doing 100 kilometers an hour, it might say display 102 kilometers an hour. Now I went and changed all of them for RDW, UK and US, so they're all exactly the same. So X equaled Y for all of those. But I suspect that comes down to the country variant, because they're all slightly different. So for example, in USA, what the actual speed was and the output was exactly the same, all the way to the point of going really, really fast, like well above 300 kilometers an hour. but all the others were the same, whereas for the rest of the world, they overread by about 2%. So I wanted to make those equal. And I know from my Speedo, just driving around and using a handheld GPS, that it does overread by about 2%. So I've changed it and now it reads correctly. So what I'm going to do is just go in here again. Let's go and select all of these. So these are all the inputs and outputs for the rest of the world. Me being Australia, I'm in the rest of the world. So as you can, so what I did on my other car that I drive every day, I just made all of the Y values down here equal those X values, save those, and then it read perfectly okay. Some other options that are available in here, for example, the G-force indicator. The actual inputs and outputs are not linear, so if you wanted to change that, there's the same sort of thing. There are 8 options for X inputs and Y outputs that if you wanted to change that. You can also change the response from the fuel gauge if you want. Not that you really need to do that, but for mine, one of the nice things, you can see how much fuel is actually in the car at the different indications. So you can see, for example, at empty, it's going to show 0 litres. When the reserve light comes on, so in the orange band on the left hand side, you know you've got 8 litres left, 18 litres at a quarter, 33 at a half, 49 at 3/4, and full is 62 litres. And what's interesting, that just shows me, well, at least I know when this light comes on, for example, or at a quarter of a tank, how much is actually in the tank. And it shows me that it's not linear. They will tell you that you've got less in it as it starts to get low than you actually have. Another option that's available to you is the bar graph. So you can see, and it's funny because in this one here, Coolmittel is actually coolant. So instead of cooling water, they call it coolant in this case. But the 2 bar graphs for coolant and oil temperature, you can adjust when it starts to indicate, when it first starts to move off the stops, and where the end is, and also where the red zone is. So let's include that one as well. So you can see that for the coolant, it starts to come off the stops at 60 degrees, the end of the graph is 155, and the red is 123. And the oil temperature starts at 60, ends at 155, and the red oil temperature is 148. So you can adjust those if you want to.